In this topic, we are going to cover project number 1, remote DLL injection. In this project, we are going to perform remote DLL injection using Python and C types. Remote DLL injection typically involves 3 steps. First, we need to allocate memory in a remote process. Next, we need to write a DLL location into that remote memory. And lastly, we need to have the external process load that DLL using load library. So let's get started by importing from C types and Win types. We can save this, project 1. Next, we can add some constants and variables that we will need to work with and start working on our function definitions. We'll need kernel 32, LPC TSTR, char pointer, and size t again. And now we can start working on our function definitions. Specifically, we will be working with some new Win32 APIs that we haven't seen before. So we'll be making use of open process, virtual alloc ex, write process memory, get module handle, get proc address, and create remote thread. So let's start with the function definitions for each of these, starting with open process. And we have a D word. We have a bool. And we have another D word. And the return value is a handle. Next, we have virtual alloc ex. And here we have the archetypes again of a handle, LP void, size t, a D word, and another D word. And the return type is an LP void. Next, we have write process memory. We have a handle, an LP void, and a pointer to size t. And the return type is a Boolean. Next, we have get module handle. The return value is a handle. Next, we have get proc address. And the return type, LP void. Next, we have create remote thread. And we have a handle. However, now a parameter is an LP security attribute, which is a pointer to a security attribute structure. So we need to know how to define this structure. And so here we can see how this structure is defined. So we need to implement this as well. So we create a new class. For this structure. Define the fields. We have a length, which is a D word. We also have an LP security descriptor. Is an LP void. And we have B inherit handle, which is a bool. And now that we have this defined, we can use it as a parameter for create remote thread. Our next parameter is size t. And now we have another unknown data type, LP thread start routine. And this is just a pointer to the application defined function to be executed by the thread. So we can say LP thread start routine is an LP void. Next, we have another LP void, a D word, and an LP D word. And the return type is a handle. And we're also going to need some constants to work with memory when calling these functions. So let's add that now as well. So we're going to need mem commit. Also going to need mem reserve. Page read write. And also execute immediately. And lastly, we need process all access. And now that we have defined our functions, the next step we need is to have a DLL to actually inject. And we can use a simple Hello World DLL to demonstrate this. So here we can see the DLL. So when we attach this DLL in the remote process, then a message box will be launched which says Hello World. So we can specify where this DLL is located. And to inject a DLL into a remote process, we also need to know that process ID. And we could also choose to start our own process, but for this project, let's instead just inject into an existing process. So let's start Notepad, which can be our sacrificial process. And in the task manager, we can find out the process ID, 2160. And now that we know the process ID, we can open a handle to that process using Open Process. And the desired access we want is process all access. We don't want to set inherit handle to be true. And we can also specify the process ID. And if we don't have a handle, then we know we have an error. Otherwise, we can print this handle out. We can execute this. Fix a typo here. And here we can see that we now have a handle to this Notepad process. And now that we have a handle, we can use virtual alloc EX to create memory in the remote process. And this function is similar to virtual alloc, which we've used before. However, using virtual alloc EX, we can specify another process in which to create memory. So we can create our remote memory using virtual alloc EX. And the parameters required are a handle, which we already have. We don't want to specify an address. The size of the memory region we want to write is going to be the size of the DLL's name plus 1. The allocation type is going to be memcommit mask with reserve. And the protection is page read write. And we can check that we have our remote memory. And if we do, we can print it out. We can execute this. Fix typo here. And here we can see that we've allocated memory at this address in the remote process. And now that the memory has been allocated, we can now use write process memory to write into that memory location. And we can see that write process memory writes data to an area of memory in a specified process. And the parameters that we need we need a handle to the process. We need the base address where we want to start our write. We need the buffer, which contains the data to be written, which is the name of our DLL, the size of the write, and we can pass in null here, because if we do, then this last parameter will be ignored and we don't need it for our purposes. We can check that our write was successful. And let's print out our memory address in hex so it's a bit easier to read. And we can take a look with Process Hacker for our Notepad process. And now we can go to this address and we can see what's written at this address. And here we can see that we've successfully written our DLL's location into this remote Notepad process's memory, into a section that we've allocated. And now that we have written into the remote process, we can start a new thread to load the DLL. To do that, we first need to know the location of load library A, which we can find using getProcAddress and getModuleHandle. So getProcAddress retrieves the address of an exported function or variable from the specified dynamic link library. So we can load our library address. And what we're looking for, the process name, is load library A. And the handle that we're after, we can use getModuleHandle to retrieve a module handle for the specified module. So we can say getModuleHandle, and we're looking for kernel32.dll. And we can print out this address. And now we have all the pieces in order to start our remote thread. And to do that, we can use the create remote thread function. And this function creates a thread that runs in the virtual address space of another process. And in order to call this function, we first need a handle. Next, we need to specify the security attributes. And we can just pass in none here. Next, we need to specify the initial size of the stack. And we can use the default value here with 0. Next, we need to pass in the start address. And this is the routine to be executed by the thread. And we want to pass in load library. Next, we want to pass in the LP parameter, which is the variable to be passed to the thread function. And we'll pass in our remote memory address because as we can see, load library loads the specified module into the address space of the calling process. And the module that we want to specify is our Hello World DLL. Next, we want to specify our creation flags, and we want this to execute immediately. And lastly, pointer to a variable that receives the thread identifier, and we can just pass in none here as well. And now, if we execute this, we can see the Hello World message box popping up here from within our Notepad process. And if we take a look now at the modules loaded by notepad.exe, we can see that our Hello World module has now been loaded within the process address space. And we should probably also call virtual free EX and close handle to clean up after ourselves too. But for this lesson, we are only really interested in executing the DLL in the remote process. And when you are testing this, you will only be able to load the DLL into the remote process once using load library. So if you want to retest an injection, you will need to choose a different process ID each time you run your script. And we can see this here in the remarks section for the load library function. If the specified module is a DLL that is not already loaded for the calling process, the system calls the DLL's DLL main function with the DLL process attach value, which we also have here in our test DLL. And so as you've seen, we've just used Python to allocate memory in a remote process, written our DLL location into that remote process's memory, and lastly, we have created a new thread in that remote process to execute our DLL. But that's it for now, and in the next lesson, we are going to cover project number 2, process creation and shellcode execution.